The Elements Book, a visual encyclopedia of the periodic table, Part 1. In this video, we will be reading through the foreword, elemental building blocks, and chemical discoveries. Foreword. Everything in nature, from the mountains and oceans to the air we breathe and food we eat, are made up of simple substances called elements. You may have already heard of several of them, including gold, iron, oxygen, and helium, but these are just 4 out of a total of 118. Many have unique and sometimes surprising chemical and physical properties. Gallium, for example, is a solid but melts in your hand. A compound of sulfur gives off the unpleasant smell of rotten eggs. Fluorine is a gas that can burn a hole straight through concrete. The elements are rarely found in their pure form. Mostly they are combined with each other to make compounds, which make up substances around us. For example, hydrogen and oxygen make water, sodium and chlorine form salt, and carbon is found in millions of compounds, many of which, including proteins and sugars, make our bodies work. To find out more about the elements, we need to take a good look at the periodic table. This is used by scientists around the world to list and detail the elements. It shows the key information for each element, grouping them into similar types. With this information, we can use the elements to make many things we need. A fluorine compound in toothpaste toughens our teeth, and silicone crystals engineered into microchips operate our gadgets and phones. Every element has its own story of where it comes from, what it can do, and how we use it. Let's begin our tour of every element one by one. It's going to be a fascinating journey. Here's a chunk of yttrium, chunk of silver, zirconium crystal bar, barium crystals, chunk of gray selenium, magnesium crystals, osmium pellet, nickel balls, cube of melting gallium, iodine in a glass sphere, chunk of uranium, gold crystals, thulium crystals, calcium crystals. Throughout this book, you will find boxes with the following symbols. This is what each of them means. This shows the structure of an atom of an element, with the nucleus made of protons and neutrons at the center and electrons surrounding it in their shells. Electron, proton, neutron. State. The state of the element of a temperature of 68 degrees Fahrenheit, 20 degrees Celsius. It can be a solid, liquid, or gas. Discovery. This details the year in which the Elemental building blocks. Elements are everywhere. Some you can see, like gold. Others are almost invisible, like oxygen gas. An element is a substance that cannot be broken up into smaller ingredients. Each one is made up of tiny building blocks called atoms, which are unique for every element. Most elements are joined with other elements to make compounds, which are made by combining 2 or more elements. This includes water, which is a compound of hydrogen and oxygen, bromine liquid with bromine gas, bismuth crystals, gold crystals. Elements in our world. There are 118 elements in the periodic table. 92 of them are found in nature, while the others are made by humans. Every element is unique. Most of the elements are solids, like the metals. At room temperature, 11 elements are gases, while bromine and mercury are the only 2 liquids. Earth, water, air, fire. Ancient ideas. The idea of elements is very old, dating back about 2,600 years to ancient Greece. However, Greek thinkers believed that the world was made of just 4 elements: earth, water, fire, and air. Empedocles, an influential scholar, was the first to propose that these elements made up all structures. Only much later did scientists learn that none of these are actually elements. For thousands of years, everybody from ancient Egyptian priests to medieval European alchemists speculated about the definition and classification of an element. Elements in and around us. About 99% of the human body is made from just 6 elements, though they are combined together to form thousands of different compounds. On the other hand, Earth's atmosphere is a mixture of gases, most of which are pure elements. About 99% of the air is made from nitrogen and oxygen. We are made of 1% phosphorus, 1% others, calcium 1.5%, nitrogen 3%, hydrogen 10%, carbon 18.5%, oxygen 65%. This is the human body. Earth's atmosphere is 78% nitrogen, oxygen is 21%, 0.9% argon, and 0.1% others. Iranian alchemists in their workshop. Alchemy and mysticism. Chemists are scientists who study elements and compounds. However, before they existed, the alchemists were medieval researchers, believing in a mixture of science and magic. Alchemists tried to change ordinary metals, such as lead, into gold. They failed because elements cannot be changed from one type to another, but in the process they discovered many new elements and developed several processes that chemists still use today. Robert Boyle, the first person to use science to understand the elements, was the Irish scientist and inventor Robert Boyle. He pursued science through reason, and in the 1660s, he performed the first chemistry experiments to show that much of what the alchemists believed was wrong. Chemical discoveries. The ancient concept of 4 elements, earth, water, fire, and air, expanded to a belief that every substance on earth was made from a mixture of these elements. However, many substances, including mercury, sulfur, and gold, did not fit this idea. Over the last 300 years, chemists have followed a long series of clues to reveal the true nature of elements, their atoms, and what happens to them during chemical reactions. Pioneering chemists. Many of the first breakthroughs in chemistry came in the 1700s from investigations into the composition of air. Chemists such as Joseph Black, Henry Cavendish, and Joseph Priestley discovered several different airs, which we now call gases. They also found that the gases could react with solid substances, which they called earths. These discoveries began a journey that revealed that there were dozens of elements, not just 4. Today, scientists have identified 118 elements, but more may be discovered in time. Antoine Lavoisier. In 1777, the French scientist Antoine Lavoisier proved that sulfur was an element. This yellow substance was familiar for thousands of years, but Lavoisier performed experiments to show that it was a simple substance that could not be divided up any further. In the same year, he also found out that water was not an element, but a compound of hydrogen and oxygen. A granule of pure sulfur. Magnesium crystals. Chunk of pure cerium. Pure cesium inside a sealed container. Humphrey Davy. In the early 19th century, the English scientist Humphrey Davy discovered several new metals. He used a revolutionary process called electrolysis, in which electric currents split chemical compounds into their elements. Davy discovered a total of 9 new elements, including magnesium, potassium, and calcium. Jacob Berzelius. In the early 1800s, the Swedish doctor Jacob Berzelius investigated chemicals in rocks and minerals. He found 2 minerals that contained new elements. He named these elements cerium after Ceres, the dwarf planet, and thorium after Thor, the Viking king of thunder. Berzelius also invented a system of using symbols and numbers that chemists still use to identify elements and compounds today. John Dalton. Like many scientists of his day, the English scientist John Dalton already believed that matter must be made of tiny particles. In 1803, he began to think about how these particles might join together. He came to realize that there are different particles for every element, and that the particles of one element all have the same mass. He also realized that the particles of different elements combine in simple proportions to make compounds. So, for example, the particles of the elements carbon and oxygen can combine to make carbon monoxide. He suggested that during a chemical reaction, the particles rearrange to make compounds. He formulated the first modern theory of atoms. There's Dalton's table of elements. Elements, states of matter. Elements can exist in 3 states of matter: solid, liquid, and gas. At room temperature, most elements are solids, 11 are gases, and only 2 are liquids. However, elements can change from one state into another. These changes don't alter the atoms of those elements, but arrange them in different ways. A solid keeps its shape and has a fixed volume. In a solid, all the atoms are attracted to each other and locked in position. A liquid takes the shape of its container, but its volume remains fixed. In a liquid, the atoms begin to move around as the attraction among them weakens. A gas will fill any container, no matter how large or small. In a gas, the atoms are weakly attracted to each other, so they all move in different directions. Robert Bunsen. The German chemist Robert Bunsen is best known for inventing a gas burner that is often used in laboratories. In the 1850s, Bunsen used such a burner, which produced a hot, clean flame, to study the unique flame colors produced by different elements. When an unknown substance made bright blue flames, he named it cesium, meaning blue sky. Thank you for watching. Look for next week's follow-up of the Elements book, Part 2, where we're going to look at an atom and the periodic table.